Welcome to Run Safe Security Minute, your fast pass to tackling tough cybersecurity questions. 1 minute, one expert, zero fluff. What are the key cybersecurity challenges facing drinking water systems, and how can they be mitigated to protect critical infrastructure and public health?
The key challenge facing drinking water systems from a cybersecurity perspective is the change in the nature of the attacker over the last 20 years. 20 years ago, you'd be looking at an attacker that was a local vandal that might want to do something just for fun or to cause local disruption. But they wouldn't be disrupting a water system outside of their local area. Someone in Georgia had nothing to fear from a vandal in California. Today, drinking water systems are being targeted by our foreign nation level adversaries, China, Russia, etc. And this was detailed by FBI Director Wray, the then NSA Director General Nakasone, CISA Director Jen Easterly, in January of 2024 to the House Select Committee on the Chinese Communist Party. What was made clear is that foreign adversaries like China are setting up cyber assets inside of critical citizen services to be able to disrupt at some future point to achieve China's geopolitical objectives, causing mass disruption in the US as a means of impacting the US's will to respond to other geopolitical events. So the impact for a drinking water system in the middle of rural Iowa or rural Georgia is that they are now facing a nation state level attacker with nation state level sophistication. And that's an unprecedented level of threat. And we're seeing this take form in numerous breaches that have been described recently, numerous vulnerabilities that have been disclosed and described pertaining to water systems. These are being investigated by the FBI, the EPA, and many others trying to get to the bottom of these attacks, but they are being perpetrated by nation state level adversaries. So what water system managers need to do, and the providers of technology into those water systems, is to be able to buttress those systems from the biggest source of risk in a way that doesn't, a way that can be achieved immediately without having to throw out systems. So, how can you, for example, in the case of memory safety, without having to rewrite all of the C and C++ code in that system, be able to get rid of an attacker's ability to weaponize memory safety vulnerabilities in the water system, which again accounts for typically 70% of the vulnerabilities in embedded systems. So looking at technologies like that allow the water system manager to get rid of as much risk as possible without having to, replace equipment, because being able to replace equipment isn't going to happen quickly. So software changes that take risk off the table is a key thing that systems should be looking for.